next presentation comes from Imanol Schlag from CSCS, where we're going to be talking about creating open and transparent language models.
Great, thank you so much for having me. My name is Imanol Schlag. I'm a research scientist at the ETH AI Center, where I lead the large language model effort together with professors from EPFL. It's actually quite nice for me to come back to Lugano. I've spent several years here, not too far from here, at USI, where I did my PhD with Jürgen Schmidt-Huber. So before we talk about the Swiss initiative in general, I'll be talking a little bit about the fast progress we have seen in AI over the last few years, in particular about large language models, and what that really is about. And excuse if, since this is quite a technical crowd, but I allowed myself to go back to a few basics. In particular, when we think about what is AI, previously, let's say before 2020, 2021, it's really all about discriminative models. And those are the sort of models we've been already using in different places. You know the models for spam classification, handwriting recognition, or for example, image classification in specific domains. But what really has sort of made the big splash is generative models, and that is quite a big difference to what we have been doing before. And the difference you can already see visualized here, whereas a discriminative model usually has labels with them, here represented by the black and red colors of each data point. In a generative model, we don't require such labels, and so we just have a distribution of the data, and so different points in this space are more likely to contain samples than others. And when you train a generative model, that generative model is capable of producing synthetic samples that, when not trained, are easily separable, but when trained, they actually quite overlap with the data distribution. And so if we are thinking about a generative model for language, we can think of each of these points being a piece of text. And so let's take an example here in German. Die Sonne scheint hell am blauen Himmel, which means like the sun shines bright in the blue sky. And so in order to measure the probability of such a sentence, we would first tokenize it into individual parts. For simplicity, we can think of it, tokenize it by words. And then this measuring the probability of the sentence is simplified by essentially just measuring the probability of this individual word. So what is the probability of the first word? What is the probability of the second word given the first? And the nice aspect of today's neural networks that we use for language modeling, since language modeling has been around for a very long time, is that these models can now be parallelized over the entire sequence to answer these questions more or less simultaneously, but at a higher cost of compute, however, parallel compute, and that's really where the cluster use comes in. Of course, this was a bit of a simplification. We usually use our so-called tokens, as you have heard probably, and those are usually word parts that can be entire words, but more often than not are just parts of a word. But now, why train a generative model? So what we've learned around 2021, and this is a figure from OpenAI's, one of the latest OpenAI publications, which is 2021, which kind of highlights really the advantage of going larger. So where previously people designed particular architectures, tried to build in very specific inductive biases into their models, what we learned is that there are really two main factors that make the model that result in the model performing better. And in particular here in the left figure, we see the test loss that decreases as a function of compute. So as we throw more compute at the problem, our ability to predict words in a context that has not seen during training improves. And so compute is really a factor of two different parts. One is an increased number of data that is being processed, and the other one is the number of parameters that the model has. So basically, if you go larger, you do better. But why large language models? Well, what we figured out eventually is that once you have just a very large generative language model, you can not just evaluate which sentences are probable and which ones are not, so in order to distinguish, for example, high-quality text from low-quality text, but you can also use it to then generate new text. And in particular, early models, you could then give an instruction, like translate English to French, you give a bunch of examples, and then you actually go and ask the model the task that you actually care about. And so the main insight here is that a strong generative model allows you to actually pull out some of these discriminative capabilities that we've been using before. And that is now basically the main advantage that these large language models provide, because you don't have to now go around and collect your task-specific data, to some extent, this can have a lot of NLP tasks in particular can be done zero-shot, meaning that all that you need to do is essentially prompt the model in a specific way, and your task is somewhat magically solved. And the capabilities that the model has, they come with the size, and they are somewhat emergent. At least that's what the community usually refers to when they talk about emergent capabilities of these models. So 2021, 2022 was sort of really the sentiment that we need to go bigger because bigger is better. We can already see here that the majority of the efforts in the dark text, in the black text, were closed models, and here in red you see the open models, and that the community in general was lagging behind OpenAI, with which GPT-3 made really the first sort of large language model effort and showed that these models can do quite interesting things, as in the example described before. However, these models were still quite problematic in the sense that they were not necessarily always that useful and required a lot of prompt engineering. In particular, you could ask GPT-3 something like, give an instruction like the following: explain the moon landing to a 6-year-old in a few sentences. And what it will spit back to you are just further explanations that you could potentially ask, since those are on the web, so not likely continuations of such a sentence. And so in 2022, the research community really sort of focused around supervised fine-tuning and alignment and tried to figure out how can we make now these models that clearly have a lot of knowledge more useful for sort of everyday tasks. And also, how can we tune the model to behave in a way that is sort of appropriate, because we don't want the model to spit out racist remarks. We want the model in general to be sort of the 3H, honest, helpful, and harmless. In particular here, I want to point out that this post-training effort is really much lower computational effort than the pre-training effort. So you can think of the pre-training as really learning a lot of facts about the world, about language, and about specific domains. But post-training really more of a behavioral training that teaches the model how to be conversational, how to follow instructions, what it means, like what sort of responses are appropriate. And also, maybe if it displays some sort of personality, some certain ideology, all of that is basically injected in that post-training phrase. And as a result, you would get something like Instruct GPT, which was from 2022, where now instead of just, well, yeah, you can see it essentially answers the question appropriately. And no surprise, shortly after then we had ChatGPT being released in November 2022, and so this really sort of started the year of the neural network-based chatbots, with also Claude from Anthropic and Gemini from Google coming up in 2023. In 2024, these methods these products essentially just have expanded in capabilities, in particular focusing on other modalities like image input or longer context, but also capability in other languages apart from English and coding, since most of these problems you could essentially just solve by expanding the training distribution of the model, and you would get some of these capabilities for free. However, 2024, the open source community also slowly catched up, because the big tech companies, the AI product companies like Google and OpenAI and Anthropic, they were not transparent about how they developed their methods. So they essentially closed the research around these models. And so they have yet to, we don't know for certain what is behind some of those latest innovations. But the open source community has really been keeping up to a good extent. And we see here the models over time. On the y-axis is performance on a very standard task that is often used to evaluate large language models, MMLU. And in red we have closed models, versus in green we have the open source models. And we see that the open source community globally slowly starts to improve and get closer to the performance of the closed models. In particular here also we're going to point out, for example, DeepSeek V2, which was released in May of 2024. And was essentially reproducing or very competitive with the Llama 3 model from Meta, which has had a lot of impact on the community. In particular, if you also look at the number of parameters that are activated in a model, right? So in a forward pass, not necessarily all parameters need to be activated, and so you can save flops and have faster inference. So in summary, the the trend in 2023 was that we want to have essentially just bigger models. But then the trend in 2024 essentially went sort of back down, where the number of activated parameters was reduced because we realized that not all of the parameters need to be active at the same time. And so that's really where you have the mixture of expert models that had the biggest impact, which came also with additional sort of engineering challenges in order to train them efficiently and also host them efficiently for inference at large scale. And that was the end of 2024, and now we're at 2025, and everyone decided to calm down and slow down a bit. But of course, that wasn't quite the case. So in January, then we had large language models, large reasoning models being released. With OpenAI 01 coming out already in September, but only 3 months afterwards with an open source sort of reproduction with DeepSeek R1 that matched or was very competitive with OpenAI performance on particular reasoning tasks like mathematics and code. And so I won't speak more about reasoning models per se. I thought that we have actually an already exciting talk on this, I think, on Wednesday. And so I'll let that speaker have some things to say about these reasoning models. I just want to say that the DeepSeek model, it comes out of a frontier lab that is sort of paid by a hedge fund, so it's not like a government thing necessarily. And the research that they've been doing, the models that they released are really excellent and high quality and perform also very well. And so DeepSeek itself, in the 2 years since its existence, has released, I think, over a dozen papers, all of them actually quite interesting from for LLM researchers. And so I think there's a few very exciting trends. On the one hand, really LLMs as sort of interactive agents, where you have the large language model in the center that has sort of the core competency and knowledge, but through tools interacts with the environment, with the external world, but also has ways of prompting itself to think more deeply and plan things, but and to some extent also interact with like a memory component. So some of these ideas have been around for quite a few years now, basically since GPT-3 came out, but now they really start to actually work to some extent. And one example to sort of push in this direction further is this MCP protocol from Anthropic, the Model Context Protocol, which kind of unifies a bit how a model is supposed to interact with external tools, such that large language models can be really trained to do well as an agent in such an environment. There have been also concerning trends, in particular one that I want to highlight here is the US export control for high-performance GPUs, where Switzerland is a tier 2. I think this is quite worth a discussion, and I feel like in general this is not ideal, and I hope that, I know that, for example, some people from the government are actually looking a bit into this as well, but it means that Switzerland, for example, would only as a nation be able to import high-performance GPUs to a certain amount over a certain time, and that could hinder research quite a bit. Although for now we're actually quite well set regarding Alps. A few other concerning trends in general is that these leading AI developers, they publish little to nothing. So over the last 2 years, it's not quite clear what has been the innovation inside these companies, and pace is pretty fast. And so we are lacking a bit we're lacking some information about this. Also, the leading open weight models, for example, like DeepSeek or Llama models, they are making the weights, the trained models openly available, but they're not very transparent necessarily about the data that they've been trained on. And so it's also not clear if they will continue this effort. And if you look at the most competitive open weight models, they're all essentially coming from big startups or tech companies. A rumor also has it that the leading efforts essentially use stolen intellectual property, and this can be a problem, especially also ethically. And we're not talking just about data that is copyright protected, but is publicly accessible. This is something that I think is not very problematic. But if you actually use data that comes from pirated sources or illegal sources, essentially, and you use that for training a model that you then want to sell. And lastly, there's an increased sentiment that AI is this sort of zero-sum game that is leading to like a fear of missing out. A lot of investment, which is probably also positive, but also some sort of isolation, and these export controls are kind of also an effect of that. And this is also not ideal in my case because I don't share that sentiment. And that's why I'm actually quite happy to be part of sort of the Swiss AI initiative, which tries to sort of push back a bit in all of these, on all of these concerning trends. The Swiss AI initiative has the goal of developing capabilities, know-how, and talent around how to build trustworthy, aligned, and transparent generative AI models, not necessarily large language models, but generative AI models in general, and make these resources, the knowledge, available to Swiss society, but really sort of fully transparently make them open source, available to anyone in the world who's interested in them. And Switzerland is really the ideal place to do so. We have the supercomputing center, of which you've already heard a lot about and know a lot about. We have the Swiss Data Science Center, which works on the intersection between industry and research, trying to sort of take the newest research insights and deploy them with industry partners. And we have excellent expertise around these models from EPFL and ETH Zurich, in particular here represented through the two AI centers, that if you would actually put together, would rival some of the largest US companies when it comes to, for example, publishing top-tier machine learning conferences. So there's a lot of know-how capability here, and the Swiss industry is actually quite capable of adapting and learning new things. So I think it's really a perfect place to think about this more deeply. In particular, so also an important part is the supercomputer that is operated by CSCS in Lugano/Mano. And the initiative itself is a pure research initiative led by ETH and EPFL. And so that's mainly where the main workforce comes from. And I would call the Alps supercomputer the de facto largest AI-ready supercomputer of a public institution. And the reason for that is that it uses NVIDIA GPUs, which allow us to use NVIDIA hardware, NVIDIA software, which makes our lives much easier when it comes to our own efforts. So the Swiss AI initiative is split into different areas and to cover different parts, different aspects, different generative models. Horizontal areas are more general purpose research directions, and verticals are more focused on specific topics. In particular, I co-lead the advanced LLM area with Antoine Bosselud and Martin Jecki from EPFL. Our goal is to train a transparent and responsibly sort of sourced large language model with a particular focus on Switzerland. Here, we want to be multilingual and multicultural from the very start with a vocabulary that sort of fairly represents different languages. We are aiming for strong performance, which, as you've seen before, mainly means a big model trained on a lot of tokens. We aim to be as open and transparent as possible. And so this means to use public data, to share a lot of information as well as results. In particular, also share the model weights with an open license that allows it to be used commercially as well and adopted by industry. We also have focused a lot on the legal aspects of training large language models. And in particular, we are aiming to be as compliant as possible with the Swiss law and the European AI Act. Now, as compliant as possible means because a lot of the questions are a bit in a gray zone, but we have actually worked with a leading data privacy lawyer in Switzerland and have established a pretty good foundation why we think that what we do is legally and mainly legally good, but hopefully also ethically good as seen by most people. And so we sort of design the foundation model from where we train our Swiss model to be really as international as possible, using not just Swiss data, but a lot of international data, in the hope that it will allow other sovereign AI efforts to actually get off the ground quicker, either by continued training from it or by using it as a teacher for the models initially. In practice, what this means is that we have a family of models that we aim to train, a 1 billion, 3 billion, 8 billion, and 17 billion model on 10 plus trillion tokens in a first phase. That should put us somewhat competitive with the Llama 3 models that have been published last summer, if I'm not mistaken. And the current status is that training has really begun on Alps on all scales. And our preliminary results that, especially on the multilingual benchmarks, where we can compare with previous intermediate checkpoints from public efforts, we are very much on track to be the state of the art in that space. Now, the goal is not just to have one publication and paper and then call it a day, but it's really to have sort of a research and release cycle where a foundation model is trained. This foundation model is then aligned according to the best effort and best knowledge at that time. And then hopefully that model is then also deployed, not just by ourselves, but by industry partners and everyone in the world who's interested in hosting this model. And we then aim to collect feedback from these deployments and then feed that back into our model foundation development and the alignment as well to have multiple cycles around this. At least the Swiss initiative has research funding for the next 4 years, so we should be able to do quite a few cycles on this. But my hope is, of course, that the models that we develop really have value not just for researchers, but for industry in general, such that we can keep this effort going. And in particular, we also see that in Europe in general, there are several national sovereign AI efforts coming up in this space. And so we are actually quite ahead and one of the first, and this will put us in a good place to collaborate with them and get those up to speed as well. Here are a few examples of how the model is already been planned to be deployed or used. In particular, Meditron is a language model tailored specifically for medical applications, in particular in environments where there are low resources, where you have very few doctors, like on certain African countries. And Meditron so far has been trained on top of a llama model, but here we hope to have a much more ethically favorable model with Swiss AI. With the Swiss AI model, there's also Ethel, which is a digital sort of tutor and teaching assistant at ETH Zurich. It already exists in its third pilot, aiming to support students in their learning, but in particular also, and almost more importantly, support teaching assistants in helping to teach and grade students. And this comes with additional challenges. You see like a handwritten text here on the left side that a model would have to understand to make the use of the model quite simple. On the right side, you see a tutor that has access to scripts in order to help the student. Lastly, one model that we are focusing on specifically, or that I am also involved in, is a large language model for Switzerland, which aims to continue pre-training our international foundation model with the Swiss data that we can get our hands on. And the goal is to better understand Swiss languages, but also sort of represent a bit the Swiss culture and society. And in particular, one of the more important use cases is also to better understand the Swiss law and sort of justice system, such that the model can be deployed at Swiss government institutions, like, for example, the Federal Tribunal, which already have been using large language models in various sort of settings. And so with this, coming to my last slide, essentially, and I invite you to think a bit more deeply about what powerful AI can do, because I think that powerful AI will sort of increasingly accelerate the ability of people who use it. And so imagine a system that knows as much as the expert literature, not necessarily the expert itself, depending on the domain, has all interfaces available with data modalities, so text, audio, and video input, and maybe also output, can use tools, in particular software tools, like Python environment, web search, etc. It can work for a query for a while. It doesn't have to basically immediately come back, but can query itself and think more deeply and come back to you in minutes, if not even hours, instead of immediately. It has no physical body and is very affordable. How will such a system really transform our work and private lives? So I personally believe that the technology can be quite impactful, but I'm not really on a hype as some of my American colleagues are maybe, but I do think that they can be quite impactful and useful, that there is value in them. And so I hope to figure out how we can extract that in a way that doesn't increase our dependence on big US tech companies. And with this, I conclude, and thank you very much for listening. I'll be happy to answer questions.
Thank you, Imanol. So we have some good time for questions.
Thank you for the nice talk, and I really appreciate the point about trying to develop a model that is trained on openly available data and being respective of copyright laws and things like that. I guess a lot of that, in my mind, goes towards the data sets that you're using to train. So how are you able to curate data sets that are free from copyrighted material or a achieve the appropriate licenses, and are you able to share those with the rest of the community?
Yeah, thank you for that question. So generally copyright, and I have discussed, I'm no lawyer, but I've discussed this now quite in depth with several lawyers and thought about this also more deeply. Copyright is really not quite how people think of what copyright is. And in English, it's actually much clearer because it's in the word itself. You have a right to create copies. And so if I have copyright becomes a problem when I train a large language model, because before I train the model, I need to actually create a local copy of my model. And the second problem, a local copy of that data before I can use it to train. And the second problem is the model capable of reproducing, creating copies of the data itself? Now, I want to point out that copyright usually really refers to a verbatim, sort of the representation of your text. It's why we in academia also learn, or in school even, that you're not allowed to copy one by one. You're allowed to paraphrase, but if you copy one by one, then you need to cite. And this is essentially the same sort of foundational idea around copyright. The ideas itself are not protected. It's your physical manifestation of those ideas that is protected. And it becomes a bit more difficult if you think about trademarks and things like that, you know. But generally, that is how copyright works. And in addition also, every human text that is written by a human has by default, that human by default has the copyright on this text. So any text that you've written that you published online is copyright protected. So the amount of copyright free or data in the public domain is extremely small compared to the amount of copyright data. Now, I think a big distinction is if the data is made publicly accessible or not. If you have given, by making the data publicly available, you have, I would argue, sort of given up certain rights around this data. And I am limited in the way that I use this, but we use it to train a large language model. And when we train a large language models on copyrighted data, we have special methods in place that have, as far as we know, not previously been used at this scale, that actually completely eliminate the model's capability of producing a copy of that data. And I can get into some technical details if you're interested, but basically the memorization problem is resolved, and the only problem sort of remains if a local copy is allowed, and usually we have no problem, legally speaking, because the data has been made publicly accessible. It's much more problematic if you use illegal sources, because then you are taking intellectual property that you have not given the right to. And if you're quite specific, then this even sort of violates Human Rights Article 27, which talks about intellectual property in general, similar to Article 17, which talks about that it is sort of a human right for people to have their own property, and you cannot just take it away from them. And so, yeah, some of these things have been discussed in detail, but of course, if you limit yourself to only public domain data, then you don't have a large language model effort.
Any other questions?
The other thing that I'm hearing about a lot about is the problem with getting enough data and enough fresh data to keep these models trained. And from what I understand, you need to have fresh, uniquely human-generated data other than synthetic data. The synthetic data tends to fall into patterns that can collapse the model over time.
Yes, so generally we don't have a problem to get around 10 trillion tokens. In fact, I think we have about double that. And we have filtered it down to the highest quality data. What that means for us is that we usually have some sort of small model that identifies if this is like natural written text or is it just a list of names or a list of places. That sort of data would be low quality and discarded. We don't train on this amount of data because it's not as useful on downstream task performance if we train on, let's say, lists of names. So when I mean high quality data, it usually is like text that a human could have written that is clearly not social media text, has little errors and things like that. There is a lot of data around. As I said, 20 trillion would still be fine, and that still hasn't touched a lot of PDFs that are available online, but a bit harder to extract.
You've got the copyright problem.
Well, yeah.
Well, you don't seem to think it's a problem, but
Yeah, we'll have to, this is still to be decided really at the larger scale. If you're using public data, I think the general sort of consensus seems to be that public data use is fine. But without getting into a debate about this, I wanted to also respond to your point about synthetic data. Synthetic data can actually be quite valuable. In particular, the reasoning models that are being trained are trained mainly with synthetic data. The main trick with synthetic data is that you need to have a process that removes the synthetic data that is useless versus the synthetic data that is good. And the way that it works with these reasoning models is that you have a sort of verifiable reward. You have a model that can verify the task to be either correct or wrong. And in those cases, you can generate a lot of synthetic and actually data and keep training on it. Yeah. And I'm also not so worried about synthetic texts being uploaded to the web that might now be in the training data set, because those texts, most of them have been uploaded and have been sort of filtered by a human, basically. So a human has seen it and deemed it good enough, valuable enough to put online, and thus it sort of passes that threshold to be quality data.
I have one question regarding maybe copyright and another one regarding the synthetic data. I mean, my understanding about copyright is exactly how you described it from the view of the European Union. I know that China basically is now saying copyright makes no sense to use it for large language models because copyright is a different concept. And China at the moment is incorporating training right law regulation, so that basically you as the data holder needs to explicitly agree to use the data for training. Because I say copyright is a different concept and it makes no sense to keep all the lawyers busy to discuss this kind of gray zone environments. I'm interested what your opinion is, and if, for example, Switzerland is also going in a similar direction or not. And the second question regarding synthetic data, when I talk to some researchers, they say that if maybe they train with a lot of synthetic data, they might run in kind of an Habsburger problem, where at the end it's more incest and the output which will be produced will be less quality. And you mentioned one option, to select it carefully so that it's something new, but how are you going to do that?
Yeah, so regarding your first question, you're not alone. David Rosenthal is that leading data privacy lawyer that we work with, who has now written a memorandum that was done in our that we asked him to do, and in that memorandum he lays out particular sort of clauses that sort of allow us to train. For example, there's a research clause. There's also a clause in Swiss law that you can create local copies of copyright-protected data for if you need it internally and stuff like that. There are limitations to those as well. But he actually also has a clause that is much more general, and that applies a bit, or is very similar to what you just said, which is that you can argue that copying data that does not have the intent and doesn't accidentally happen to, like, it doesn't have the intent for another human to consume that data. And so you can ask if the copying of that data is even copyright relevant, because no human is actually going to consume that data ever. It's way too much and it's in a format that is not applied to it, and it's closed and only a few people have access to it. So this is actually an argument that he also brings up, but it is highly contested. Like, people don't feel very good with it, but it's hard to bring a good counter argument. Copyright has had a problem with the digital world since the beginning, since we started having the internet and stuff like that, and this is an ongoing effort, and maybe this will require some reinterpretation of copyright, but you would have to ask a lawyer on this. Oh, you had a second question.
Thank you for the great talk. My question is a bit on a different topic. You've discussed building sort of large language models, but there are definitely applications where it would be very beneficial to have a smaller, locally running language model. Are you doing any research, for example, on deploying language models on edge computing hardware, or are you planning to do any? I'm just curious to see sort of what the status is in.
Yes, we actually started training a few smaller models to see if everything's on track and we're doing the right thing, which we are. And those have been 3 smaller models, one at 3 billion parameters, 1 billion parameters, 3 billion parameters, and 8 billion parameters. I think some of those can definitely run on the edge. I'm not so sure what sort of edge you had in mind, but I mean, at some point you just need some amount of parameters to do well. You can get away with like a mixture of expert approach where you have fewer parameters that are being active, so you need fewer flops on your device, but you would still need storage and a fast interconnect in order to, you know, load that memory or load it from your storage into memory to do well. So we are definitely thinking about some of these, but the biggest performance comes with the bigger model, and so that's what we are focusing on. But yeah, the family right now is 1 billion, 3 billion, 8 billion, and 70 billion.
Thanks.
Okay, last question over here.
So lucky for last question. So my question is, since during the past 2 years we have already trained a lot of large language model for pre-training for the foundation model, then this stage for the industry, our effort are put on the post-training, fine-tuning, and also the AI agent for application. So based on your experience, what's your opinion? Do we still need to put some effort on the foundation model training in the next phase or not?
Well, generally, the community has acknowledged that scaling to larger models is not necessarily the solution because people have started to realize that it's quite expensive to serve large models. But there is a lot of efforts that try to either distill the large model or, you know, train a smaller model with like the experience, the lessons learned from training a large model. So generally speaking, the community is moving away from just bigger and bigger models, unless you want to train a very big model to really distill it into a small, more nimble model, which is actually quite a good approach, and also what the Llama 4 model or Meta actually did with the most recent ones. For us, it's not necessarily just about training the models, it's also about the know-how and the talent around these models. And here, the pre-training is a very important part because it's the one that requires the most computational resources. And once the models are trained, you know, they're frozen. They don't learn on their own. So we will require to retrain to a certain degree as we continue in the future with maybe lower precision, depending a little bit on what the hardware capabilities allow us to do. And so I think it's definitely a good exercise to maintain that knowledge. Yeah. So I think pre-training can still be important, but not necessarily for the people who are building products. Those should more focus on maybe using services that are reliable, that are doing well, and can be integrated well, and yeah, into a system with tools that work particularly well in their domain, where they have the domain expertise and also understand what is required, since most of the model builders don't know what the model will be capable of. Thanks.
Thank you, Imanol Schlag.